Hello and welcome back. And in this video, we're going to be building our queue using LinkedList. Okay, so let's go ahead and get started. Before we build our queue using LinkedList, we're going to need our node class once again. So let's go ahead and create a node. And we're going to create a simple node class. And it's going to have data. And it's going to have next, which is going to be of type node optional. When we initialize, we can simply say optional parameter can be passed in, which is going to be data. And we're going to say cell dot data is equal to data. Okay. Then we can create our queue linked list, or you can say LLQ. That's it. There you go. Okay. So now we can create our queue using linked list. Okay, so let's create a class this time. I'm going to call this LLQ. And we're going to create three variables. One is going to be head. This is going to be representing the start or the head of the queue. And next one is going to be tail. It's going to be the end of the queue where we're going to do the extraction from, right? So head is where we're going to insert, and tail is where we're going to remove the item for, okay? So, and we also going to need length, okay? Length of the queue. So basically how long the queue has been, okay? So we're going to make this private, and private, unless we need to expose this one later on. Okay, now let's create our function enqueue, and we're going to expect it to supply some data. And what do we do? Okay, so first of all, we say length plus equal 1. Okay, first and foremost. Now let's create a node with data, and we need to do a check. The check is going to be basically checking if the queue is empty. So if our head is pointing to a nil, so if our head is nil, that means this is the first time queue is being created, or all the items have been removed from the queue. So we need to actually insert a new item at the head. So we simply say head is equal to node. Tail is also going to point to the same element, and we return from here. Okay, so that actually creates or populates our queue. Okay, if that is not the case, that means we have something at the tail, and we simply say tail.next is equal to node. Okay, so if it's the first item, then basically you have tail pointing at head, or like the beginning element. So you say tail.next is equal to node. Now you update your tail saying tail is equal to node. That way, tail pointer starts to point at the new node memory address. Okay, and that's how you actually enqueue an item into the queue. Now, if you take dequeue operation, where we are returning a node. Now here, if we check if the head is nil, right? If the head is nil, well, we need to return nil because we cannot proceed from here on, okay? And if the head is not nil, that means we need to insert an item or we need to remove an item. So we simply say length, first remove our length or decrease our length, and we say node is head, and the head is basically head.next, right? So you're so basically what you're doing is you're removing from head, and when you're removing from head, you want to actually point the head wherever the head is, point the head to the next item of the head. Okay, so you move that pointer to the next item, and that becomes your new head, and then you simply return your node. All right, and then you have peak, and also return an optional node. And this one is very simple, so you simply return head. Okay. Now, last item we can implement is empty because it's going to help us build our functionality. And we're going to have it return a boolean. So we're going to say return length is equal to 0 check. Okay. So if the length is equal to 0, that means our queue has been empty, has become empty now. Okay. So with this is our implementation for linked list based queues. It should be relatively easy because it looks exactly like linked list or stack implementation. It's just the enqueue and dequeue operation is a bit like flipped. So spend a moment understanding this. Go over this a couple of times if it doesn't make sense, and hopefully it'll make sense. Okay. So, or like, if you look at like, over and over, like, just put some debug points, it's going to help you understand how it's actually working. Okay. Let's go ahead and go into our main now. And what we're going to do is we're going to change it to LLQ. And I want to actually run it just like that to see if there's any issue. Yeah. So queue.isEmpty is a function. So let's go ahead and change it into a var. Okay, so line must be separated. Yeah, same thing. Oh, return type. Yeah. Okay, so there we have that. And do you mean explicit? Okay, so we are returning a node. So what we can do is we can simply say we know that this is not gonna be nil, and we can simply say dq.data. Okay, so there we go. We have our linked list based queues, and as you can see, we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 being inserted or enqueued, and then when we are dequeuing, we are getting that same. Okay, and if you try to print queue dot peak, let's see what happens. So queue dot peak, yeah. If you run that, you get dot data. I'm going to just type that this is the peak operation. That way we know. There we go. So peak is 0. That means our first item that will be removed is going to be 0, which we know it is because that was the first item we inserted, and then all the other items following that. All right. So that's it for this video, and now you learned how to create queues using arrays and linked lists. So in the next video, we're gonna start understanding. First, let's understand the theory behind LRU cache, and then we're gonna look at the implementation of how you can build this custom data structure to achieve what you want to create using queues. Okay, so let's go ahead and hop onto the next video, and we're gonna take a look at LRU cache. Thank you very much, and I'll see you guys in the next video.